Question number 51. The de Broglie wavelength for an electron moving with kinetic energy of 4.55 into 10 raised to the power minus 23 joule is. We have the value of kinetic energy. That's given here. And we have to find out de Broglie wavelength of an electron. And the data is also given, the value of H and the value of mass of electron is also given. And this question can be solved with the help of the formula that K is equals to half mv square. From this formula, we can calculate the value of V. The value of V would be equal to root of 2K divided by M. And what is M here? M is the mass of electrons. So that can be represented by ME. Now, in this case, we have the value of K. So we can find out the value of V also. V would be root of 2 into K. That is 4.55 into 10 raised to the power minus 23 joule divided by the mass of the electron. That is 9.1 into 10 raised to the power minus 31, the simple form. Now, after this, we just have to find out the de Broglie wavelength. That is lambda is equals to H by M V. So, let's place the value here. The value of H is 6.626 into 10 raised to the power minus 34. That's given in the question, joule second. Now, after which we have MV. M is 9.1 into 10 raised to the power minus 31. This is M value. And what is the value of V here? V is root 2 into 4.55 into 10 raised to the power minus 23 divided by 9.1 into 10 raised to the power minus 31. This would be the value. Now, if you solve this for the value of lambda, you will find out that the value is 72.81 into 10 raised to the power minus 9. That is in meter. And that can be written as 72.81 nanometer. This is the final value that we have to calculate. Let's mark the correct answer on the basis of this. It is option 3. Answer is option 3. I hope this question is also clear to you. Let's check what is given in the next question. Question number 52. Ratio of sigma and pi bonds present in C3O2. What is that? Carbon suboxide is. In this question, we have to first check what is the structure of this C3O2. In this case, the structure can be drawn like this. Now, this is the structure that you have here. And now, we can see that the sigma bonds are here and the pi bonds are here. Now, the ratio of sigma bond and pi bond. It means the sigma bonds, the total number of the sigma bond upon total number of the pi bonds is 4 by 4 and the ratio is 1:1. Now, on this basis, the option 4 is the correct option. Now, after this, the next question. Question number 53. If the distance between hydrogen and chlorine atoms in HCl molecule is 1.27 into 10 to the power minus 8 centimeter and dipole moment of HCl is 1.03 dBi, then approximate percentage covalent character is HCl molecule is. In this question, we have to find out the percent covalent character. We know that the percent ionic character, if you want to find out, of a compound is equal to mu observed upon mu theoretical. Now, what is this mu? Mu is the dipole moment into 100. So, with the help of this formula, we can find out the percentage ionic character, and if we subtract it from 100, we can find out the covalent character also in percentage. So, let's first find out the mu theoretical value. We have the mu observed value. I'll write here. Mu observed is given, and that is 1.03 dBi. Now, the mu theoretical for this case is equal to Q into D. We are talking about HCl molecule, and that charge is 1.6 into 10 raised to the power minus 19 coulomb. And what is the value of D? Distance. The distance is clearly given here. If you look here, that is 1.27 into 10 raised to the power minus 8 centimeter. So it is 1.27 into 10 raised to the power minus 8 centimeter. But we need it in meter because we have to find out the value of this theoretical dipole moment in dBi. So I'll change it into meter. So this is in coulomb meter. Now, this value is 2.032 into 10 to the power minus 29. And now let's change it in dBi. After calculation, that is 6.1 dBi. Now we have the mu observed as well as mu theoretical also. We can find out the percentage ionic character. That would be mu observed, that is 1.03 divided by 6.1 into 100. This value is approximately 16.88%. Now, if it is so, what would be the percent covalent character? Is equal to 100 minus 16.88. And if you solve this, you will find out this is 83.12%. Now, if it is so, the correct answer is option 3, and that I'm just going to write here. Now, I hope this question is also clear to you. Now, let's check the next question. Question number 54. Select the endothermic process among the following. We have the different processes given here. Beryllium is there, electron is added to it in first option. In the second option, we can see sodium atom is there, electron is added, then fluorine, and then oxygen. So if you check the first option, that is beryllium, and electron is added to it to form beryllium anion. In this case, if you consider the configuration of beryllium, it is 1s2, 2s2. So this is the configuration which is a stable configuration, and that is showing the completely filled (2s2) configuration. And it is quite difficult to add an electron to this beryllium atom because it has a very small size, and already electronic configuration we have discussed. While in other options, if you look at, you will see that electron can be added. The process is not endothermic, and if it is so, this is the correct option. The answer is option 1. After that, we have the next question. That is the question number 55. Total spin value of Fe2 plus ion is. For this, we have to find out its electronic configuration. Atomic number of Fe is 26, and its configuration can be written as (3d6 4s2). This is the configuration. But if we talk about Fe2 plus ion, the configuration would be Ar 3d6, and the filling of d orbital can be represented the electrons are present here. 6 electron will fill as per Hund's rule. 6 electrons are filled. Now there are 4 unpaired electrons. And now the total spin is half into 4, that is 2, and the correct answer is option 1.